Hi, everyone. This is Evan McLaughlin. I'm a marketing content manager at Minitab. I want to thank you for joining our webinar today, Tips and Tricks for CART, or Classification and Regression Trees in Minitab statistical software. A few housekeeping notes before we begin. I wanted to say the webinar audio is available through your computer. For the best audio quality, please make sure your speakers or headsets are turned on and the volume is up. Some networks might cause slides to advance more slowly than others. So if you see that issue, you might need to log off your VPN to help with that, or sometimes just closing out the window and then logging back in if you see some slowness can take care of everything for you. I want to note also, this webinar is being recorded. We'll send the presentation and the recording by email afterwards. So don't worry if you need to drop off or want to review anything later. You'll get that email later on and you'll be able to see everything from there. Also, you should see a questions pane in the GoToWebinar controls. If you have any questions for us, please go ahead. We'll contact you. If we don't answer it right now, we'll contact you personally after the webinar to follow up and help answer them. We are also, after this closes out, you'll see a couple survey questions after the webinar is over. So we'd appreciate it if you could take a few minutes to answer those. It sort of helps us tailor the content to what you guys are looking for. And I wanted to introduce our presenter today, Marilyn Wheatley. Marilyn is a solutions architect. She's trilingual as well, which is very helpful. She has helped Minitab customers knowing the software back and forth in Spanish, Portuguese, and English, training them how to make graphs and visualizations, gain insights, make their best data-driven decisions. You can see more about her credentials here. She earned her Six Sigma Black Belt certification from Arizona State and a certificate in applied statistics from Penn State and a master's degree in economics from Eastern Michigan University. So without further ado, I'll hand it over to you, Marilyn. Marilyn?
Great, thank you, Evan. And so today you can see the agenda for today's presentation. I actually added another section here. I'm going to give you a quick overview on CART for any of you that are a little bit less familiar and haven't had a chance to check out some of those other webinars that Evan had mentioned. Then we'll dive into tips and tricks for manipulating the view of your CART models. We'll explore a few tips for sort of further investigating your CART results with more visualizations. We'll talk about adding penalties for specific data conditions, and then we'll talk about some best practices for your results, right? So quickly again, for anybody who's a little bit less familiar with CART, we wanted to start out by giving you an idea of how CART can help address some business challenges, just at a high level. And these examples of how CART can help are from real Minitab customers. So these are real use cases for how other organizations are using CART to solve some of their toughest business challenges. The first example here is related to manufacturing and a producer of consumer goods that needed to reduce their downtime, unplanned downtime for machinery. So CART helped them identify the top drivers of equipment breakdowns and the rules that indicate that preventative maintenance is required to avoid unplanned downtime. We also have an example here from healthcare. This was a Canadian regional healthcare provider that had experienced some issues back in 2003 where infections were transmitted from patients to healthcare workers, and they needed a way to prevent that from happening again with COVID-19. So CART was used to pinpoint the risk factors of transmission from patients to healthcare workers. And this regional healthcare system was able to proactively protect their staff through updated protocols and PPE standards. Another example from a financial services provider, they actually used CART to determine customer characteristics that were associated with high default rates. So they developed some profiles to anticipate higher risk clients. And lastly, customer churn that would be relevant in most industries. Most of us are looking to keep our customers. And this particular case was from a mid-sized US commercial bank that was losing quite a bit of their customers. They were able to use CART to identify the customers that were at higher risk of churning. And they used that to develop targeted marketing campaigns for each customer segment, thereby successfully reducing their year-over-year churn by 5% and boosting profits by 20%. So hopefully this gives you a high-level idea of the types of scenarios in which CART can be useful to you. And again, for those of you that are a little bit less familiar, I want to give you a quick overview about what CART is before we get started. So this is a new predictive analytics feature that was added to Minitab in version 19.2020. And to check your version of Minitab, you can use the Help menu and choose the option titled About Minitab. If you have a version prior, an older version of Minitab, anything prior to 19.2020, you'll want to upgrade to see this feature. And today I'll be showing you Minitab 20. Again, if you have a previous version, you may want to update that. In a lot of cases, it's just a matter of getting IT to install the new version for you. You may have access to it at no additional charge. So CART here offers tree-based machine learning within Minitab's interface. And I say tree-based because the models look like a decision tree, like the example that you can see on the right-hand side of your screen. And there are two types of CART models. The choice depends on the type of response or outcome variable that you want to predict. So when the Y or response or outcome is a continuous variable, we can use CART regression. And when the Y or outcome we want to predict is categorical, and that can be two or more categories in the outcome, in that case, we would use CART classification. And this type of model is really ideal for large observational data sets. This is a non-parametric method that offers automatic variable selection, and the results are really easy to interpret. Okay, and with that, I want to share with you some quick CART terminology that is going to be relevant to today's tips presentation, right? So quickly, just an overview of some CART terminology. You see a CART tree. In this case, it's a classification tree that you see on your screen. And so as we build a model, it all starts with the root node that is the starting point of the decision tree. And this root node represents all of the data that we're using to create our model. Next, we have splitters. The splitters are the decision rules that define how the data is partitioned in each of these nodes. And these decision rules are based on the levels of the predictors that you incorporate in your model. And Minitab finds these splitters as part of this analysis. Next, we have what is called a decision node. That is a node that is going to be split again into two nodes. You'll notice that each time the data is split up, it is split into two separate groups. And then lastly, here we have what is called a terminal node. So these are nodes or groups of data that are not going to be further split. These are the final groupings that we can predict for based on the decision rules. So in this case, the terminal node that is marked in blue, the decision rules that are that the line speed is greater than 245 and the diameter is less than or equal to 17.5. So here, line speed and diameter were two of the predictors in this model. In this classification tree, the terminal nodes in red are predicted as being a product that is out of spec, and the blue terminal nodes are predicted as in spec. Okay. And so in terms of the predictions, if we're running, if we have a continuous response, we use CART for regression. And in that case, the prediction in each terminal node is the mean or average. So the path to the node tells you the rules, and the terminal node predicts the average given that particular set of rules. Now, if we're talking about a categorical response, again, it can be two or more categories. This example tree here has two categories in the response. In those cases, we use CART for classification. And the prediction in the terminal nodes is the event probability, which we'll talk more about later today. and the predicted class, in this case, in or out of spec. And again, the path to each terminal node defines the rules based on the predictors, and the terminal node has the prediction. Here, the probability of the event for the classification tree. All right. So hopefully that this quick overview is helpful to you as we jump in and start talking about tricks for manipulating the view of CART models. So for this first section, I'll just be in PowerPoint to take you through a few basic tips for managing the view of your CART models. Okay, so starting out here, even with a small number of predictors, the optimal CART tree that Minitab recommends can be pretty large. There can be a lot of terminal nodes, right? So in this case, something that is really useful is you can right-click on your tree and choose the option titled Node Split View. And this is going to give you a condensed view of the tree, which you can see to the right-hand side. So instead of seeing all of the details, this condensed view of the tree just shows which predictor was used to partition the data each time that the data was split. And in this example here, we have a classification tree with 3 levels in this categorical response. So you can see that in the legend, in the node split view on the right, that shows 3 categories of the outcome or Y variable in this model. So in the condensed view, we can also see which response level, 1, 2, or 3, is predicted within the tree. So the terminal nodes in blue in the tree to the right are the predictions for response level 1. Red terminal nodes are the predictions for response level 2, and in yellow are the predictions for response level 3. So in this case, if we're interested in quickly identifying the predictors that were used at each split, or what category of the response each of the terminal nodes are associated with, we can quickly identify that using node split view. All right, so next, a little bit more about manipulating the view of CART models. I want to tell you a little bit about this option to zoom to fit. So this option is also available if you're seeing the detailed view of the tree, and you can use this whether you're viewing something that's too big to fit the window or too small to see. So you can right-click to choose this option, or you can see I've highlighted the icon for this option in the upper right-hand corner of the window there. So 2 different ways to get to the same thing. And this is really just going to make it easier for you to see more details if you have a small tree. So in this case, I'd selected to see the node split view. That's that condensed view that we talked about previously. And zooming in to fit the to make the tree fit the window makes it easier to see everything together here. All right, so a little bit more on manipulating the view. So to see the detailed view of a large tree, I like to line up the vertical and horizontal scroll bars in the window that displays the tree-based model. I like to line these up in the lower right corner of my screen so I can use them to pan and move around that large tree to see all of the details. Again, this is really useful when you have a really large CART model with a lot of terminal nodes. So if we want to see all the details of the decision rules down one branch of a large tree, this could be a good option for viewing that. And just a little bit more on manipulating the view of these CART models. Now this option is only for regression trees. Because when the response is continuous, again, that prediction in each terminal node is for the average response in that grouping. So here we can right-click on our tree and choose to highlight the 5 nodes with the highest means. So if we were interested in increasing or maximizing the value of our response given the input settings, this could quickly help us identify what set of rules to use to maximize or increase that response value. Similarly, we can click to highlight the 5 nodes with the lowest averages. So if our objective is to minimize our outcome or response variable, this could quickly help us identify what rules we need to implement to get us there. And of course, we can right-click on any individual node to copy the rules that will lead to that specific predicted value. All right. And with that, let's move on to our next section here. I want to share with you some tips for exploring your results of your CART model. And before we jump into Minitab, I want to quickly introduce you to the data sets that we'll be working with today. So our first data set is for our regression tree. This data is from an analyst that would like to understand the drivers of a high Net Promoter Score. And Net Promoter Score, you can see a description there to the right. It is a score that measures customer satisfaction on a scale of 0 to 10. Customers were asked how likely they are to recommend the company's services. Right? And we're going to make a prediction about Net Promoter Score based on the predictors that you see listed on the left-hand side there. So things like, was the website easy to navigate? Does the person feel valued as a customer? What was the type of transaction? Their location within the United States? So a mix of continuous and categorical predictors. And so the histogram on the right-hand side there shows you the distribution of the response, the Net Promoter Score. So you can see how many observations were associated with each of those Net Promoter Score ratings. So that's our regression tree data for today. We're also going to work through a classification tree example. And this data is from an engineer that is trying to understand what factors and settings contribute to product that is outside of the spec limits. So you saw an example of this tree a little bit earlier in the presentation. So the response is whether the observation is in or out of spec, and you can see the distribution of the response there in this Pareto chart. And the predictors or inputs that we're using to make a prediction about the observation being in or out of spec are on the left-hand side, things like the location, the line speed, the diameter, and so forth. Great, so now I've introduced you to the data sets we'll be working with. Let me pop my Minitab open, and here I'm going to be showing you Minitab 20. One thing I want to point out is we've got some great new visualizations within Minitab 20, things like our new bin scatter plot, our parallel coordinates plot, and also this heat map. So I'll be showing you an example with the heat map a little bit later. So let's go ahead and create our CART regression model. We're going to be working with the NPS data set that you see here in my worksheet. The response is in column 1, and we'll use the columns to the right to build our model and make a prediction. So I'm going to go to the Stat menu, and the option is available here under Predictive Analytics, and I'll choose CART for regression since I have a continuous response. I'll fill in the Net Promoter Score. I'll fill in all of my continuous predictors here in the first field, and then I'll add my categorical predictors in the second field. And so before we go ahead and run this, under this storage option, this is our first tip here. So if you recall, I mentioned that the final groupings or terminal nodes make a prediction about the average for that grouping. So what we're going to do here in storage is we're going to actually store those fits or predictions in our worksheet along with the corresponding terminal node ID, right? And I'm going to go ahead and click OK. Click OK again to run my tree. Here we go. We have an 18 node CART tree. We can see the details here in our output pane. Again, 18 nodes referring to the 18 final groupings that Minitab identified in this data set. I do want to point out, as I said, these terminal nodes are numbered in the output from left to right. And so if I go to my tree here, we can see that these are numbered, numbers 4, 6, 7, 8, and so forth, as well as we can see those averages, those predictions in the terminal nodes. So what I did when I created this CART tree is I stored those values here in the worksheet. So we get the predicted value in each terminal node as well as the terminal node ID, and we're going to use this information to further explore the results of our CART model. So if I scroll down in the output pane, one of the nice things about CART is that we get automated variable selection. And here this relative importance graph shows us which predictors are important or what's driving a high or low Net Promoter Score. You can see we've got the state, whether the person feels valued as a customer, the type of transaction, and so forth. So the first visualization I want to show you, or idea I want to give you for how you could explore these CART results, is that given that we stored the predictions in the worksheet, we could easily use one of Minitab's visualization options. In this case, I'm going to use a box plot to visualize these predictions, or fits as they're titled here, by the various levels of a categorical predictor. So in my case, I'm looking at the relative variable importance graph to the left, and I'd like to visualize the transaction type and how that is affecting the Net Promoter Score. And so here I've created a box plot so that I can easily visualize at the different levels of a categorical predictor, how do these predictions behave? So I can see if the type of transaction is repair. Generally speaking, those Net Promoter Score predictions are a bit lower, a bit higher for refund, and it looks like they're maybe the highest here for when the customers get a replacement. All right. So storing the fits in the worksheet to visualize how our predictions behave across the ranges of the different levels of a categorical predictor could be helpful. Another thing you might want to do is visualize those predictions across levels of more than one categorical predictor. And a nice new option that we have here in Minitab 20 for doing that is the new heat map, which is also available here from the graph menu. So if I choose heat map, I'm interested in graphing the predicted fits. I'm going to say the row variable is going to be the state. Remember, if you recall, that was an important predictor according to the relative variable importance graph in our CART output. And notice here we could include up to 5 categorical predictors for the rows. And here as a column variable for this heat map, I'm going to go ahead and include 2 categorical predictors. I think we're going to include whether the person feels valued as a customer. That was also important according to our CART analysis, as well as the transaction type. All right, and now go ahead and click OK here, and you'll see this gives us a nice visualization, a nice way to see how our predictions behave according to different combinations of our input variables. So you see on the left-hand side here, we have the state, and at the top, we've got 2 different categories. The 0 to 10 is whether the person feels valued as a customer, and then we also have the transaction type, repair, refund, or replacement, right? And we can hover over each of these different segments to visualize what the predictions are based on that particular combination of inputs. The legend on the right-hand side there, you can see that a deep red indicates a higher predicted value for Net Promoter Score, and the dark blue would be a particularly low score for Net Promoter Score according to our predictions. And within this heat map, I can also scroll down to visualize details for all of these other states. So this is a nice way to visualize your predictions across the different values of your predictors. And it's pretty nice because it's not too cluttered. You can still see everything quite clearly and get more details by hovering over any particular areas of interest. Great. So in terms of this regression tree, I do want to show you one more thing that you might be interested in doing. And in this case, we're going to use one more visualization. I'm actually going to create just a regular scatter plot of X versus Y. And what I'm going to be plotting are the predictions or fits from our CART regression model by the terminal node IDs. And if you recall, or you can see on the left-hand side there in the navigator, this is an 18 node CART tree. So I'll go ahead and generate a scatter plot. and I'm going to bring it out here in edit mode so that I can go ahead and brush these predictions using our brushing tool. So here, I'm going to highlight this particular node where it looks like the predicted fit is really low. In fact, the predicted value for this terminal node ID 1 is 0.42, so pretty close to 0. These customers are pretty unhappy with us. And so another thing I might be interested in doing here is knowing more about who these customers are. I might want to go ahead and add the customer ID to the display on the right. And in fact, I might want to highlight all of these groups where the predicted Net Promoter Score is really low. These customers have had a bad experience with the company, and I might want to see if there's something I can do to follow up with these particular individuals to salvage the relationship or improve their experience with our company. So once I have this highlighted, I might want to go ahead and use the data menu, and I can from here subset this worksheet using the brushed rows from the graph, and I might want to include only the brushed rows, right? So maybe I can title my new worksheet Unhappy Customers, and if I click OK, you'll notice here at the bottom I have a new worksheet that includes only those rows where the predicted value for Net Promoter Score is really low, so I can do some further investigation with those particular customers. Right? So those are the examples I wanted to walk you through in terms of a regression tree here within Minitab. Next, I'd like to show you some things that you could try out working a classification tree. And to do that, I'm actually going to show you the new Minitab web app. So let me bring that up here. This is the Minitab web app. You can see I've got the out of spec data that we talked about a little bit earlier in PowerPoint. We're going to use, looks like we have some security features here. If you don't use it for about 15 minutes, this times out. So I just had to log back in, and I'll go ahead and re-import this data. It's no problem. If I go to File, Open, I'm actually going to open a worksheet, and you'll notice we have different options for where we can retrieve the data from. We could open some data from Microsoft OneDrive or Google Drive. I'm just going to open up a worksheet that I have saved on my local computer. It's this out of spec data set here, and I'll click open and bring that worksheet back in here so we can run our cart tree. The other thing I'm going to do is actually I'm going to go ahead and save this file. I'm going to save a copy, and I'm going to save it to Microsoft OneDrive because I want to show you that we can share this analysis after we run our cart tree. So I'm going to say this is out of spec data. I'm going to save it to Microsoft OneDrive, and I'm going to specify the folder location for the save. I'm just going to go ahead and I'll just leave it in my files. I'll put it in my desktop. There we go. Hit save. And so notice that as I set the save here, what's going to happen in the web app at the top, it's telling us this is saved. We have auto save on, so as we make changes to the file, those are automatically going to be saved to that cloud repository in OneDrive, which you can see here to the left side. So I'll go ahead and run my tree. I'm going to go back into Stat, Predictive Analytics, and this time I'm going to choose Cart for Classification. And our response or outcome that we want to predict is binary. It is in the column titled Target. And notice here that the response event of interest is out of spec. So we're interested in what is driving out of spec product. I'm going to enter my continuous predictors in the first field and the site ID and the die manufacturer as categorical predictors in the second field. And again here with the classification tree, we're going to click on storage to store our predictions in the worksheet. If you recall, for a classification tree, the predictions are the predicted probability of the event. We could also store the predicted response level. I'm going to leave that for now, but we are going to store the terminal node IDs again once again here in the worksheet. So I'll click OK again. And we get the same cart model that we would get if we were using the desktop application. We can see the output there in the output pane. In fact, I'm going to scroll down so that we can take a look again at the relative variable importance graph so we know which predictors are important. It looks like the line speed, the diameter, and the temperature are important. And now I'm going to use the stored probabilities in my worksheet to visualize some of these predictors relative to the predicted probability of the observation being in or out of spec. Now, if you recall, we said the prediction is the predicted probability. We're looking at the probability of the event being whether the observation is out of spec, right? So this is the response of interest here, or the prediction of interest. And for this, I'm actually going to go back into the graph menu, and we are going to visualize this on a contour plot. I think you'll find this really helpful. So here we're going to view the probability that an observation is out of spec at different levels of the line speed and the diameter, which we can see to the left are the two most important predictors. And here I'm just going to go ahead and click OK. And here we have a nice contour plot where we can hover over it. We can see at the various levels of line speed what the probability of being out of spec is. Same with the diameter. So at lower line speeds down here, it looks like the predicted probability of the part being out of spec is greater. As we increase the line speed and increase the diameter here in this lighter green area, we can see there's a lower probability of that observation being out of spec. So this could quickly help us identify better settings for our inputs that will increase or decrease the probability of the event of interest. And same thing for the other continuous predictors. I think a contour plot is a really nice way to visualize the probability of the event relative to those continuous predictors. All right. So with that, let me bounce back over to PowerPoint. We're going to quickly recap what we've covered here, and we'll move on to the next section of today's presentation. So just to summarize, again, you can store the fits or predictions for your cart models into your worksheet using the storage option in Minitab. So for a continuous response, the predictions are the averages in each terminal node. That is titled fit here in this window, and you can check that box to store the predicted fits in the worksheet for a regression tree. And for a classification tree, you can store the predicted probability for the response levels. As you can see there, click OK, store that in the worksheet, and you can work with Minitab's visualizations to further explore your results of your cart model. One of the ideas that I shared with you is that the stored fits or predictions can be visualized on a contour plot along with two continuous predictors to visualize some of the hotspots. Also, the stored fits can be graphed on a box plot or other graph to visualize those predictions at various levels of a categorical predictor. And today I showed you two examples of that, one with a box plot. And then we also use the new heat map to visualize the predicted response values at various levels of multiple categorical predictors. So a nice new option to visualize things on that heat map. And of course, we can also graph the predicted values by the terminal node IDs. And then we can use the brushing tool to zero in on particular observations. In the example that we saw today, we're going to use this information to zero in on and potentially further investigate customers that gave low ratings to hopefully salvage those relationships and see what we can do to improve the experience for those customers. All right. So now that we've looked at some visualizations or options for exploring your cart results visually, let's talk about options for setting some penalties. So penalties for specific data conditions. And so you might be asking yourself, what data conditions are we talking about here specifically? Well, there's two different data conditions that I want to talk to you about today. The first one would be categorical predictors or inputs with many levels, right? So a predictor that is categorical and has a lot of different levels. And the other data condition involves predictors. This could be continuous or categorical with a lot of missing values, okay? So why are these problematic? Well, because a categorical predictor that has a lot of levels can essentially distort a tree due to its increased splitting power. Essentially, they have an advantage over predictors with less levels. So we can apply a penalty to sort of stop a categorical predictor with a lot of levels from sort of taking over the tree and sort of masking or covering up the effect of other predictors that are truly important, all right? For categorical predictors with a lot of levels, the penalty that you can set ranges from 0 to 5, where 0 is no penalty whatsoever and 5 is the highest possible penalty. And so in a similar way, predictors that are continuous or categorical and have a lot of missing values, they can also sort of take over the tree. They also have increased splitting power just because of the fact that they have a lot of missing values, and you don't want that predictor to appear more important than it is. So you could set a penalty for predictors that are continuous or categorical and have a lot of missing values. Now the penalty for this data condition ranges from 0 to 2, where 0 is no penalty and 2 is the highest possible penalty. And I do want to point out here that these data conditions are related only to the predictors or inputs and not the type of response or outcome that we want to predict. So we can have either of these scenarios with classification or regression trees, and therefore we can set these penalties for both types of models within Minitab. And I'm going to show you that live in the software. So to do that, let me bring back my Minitab desktop application. Here we go. And so this time we're going to set penalties for our regression tree before we run the tree. So to set these penalties, you can go to File, Options. And I do want to point out that any changes that you make to the application options in this menu would need to be changed back in this menu, or they will be your new defaults going forward. So here I'm going to expand predictive analytics on the left-hand side, and you see that we have options to set our defaults for both classification trees and regression trees, right? In my case, we're going to be working with the NPS data and running the regression tree again. So I'm going to set the penalties here. In particular, I'm thinking about the state, right? There's a lot of states in the United States, and so that particular categorical predictor has a lot of levels. So I'm going to set the high level category penalty here, which ranges from 0 to 5. And we're just going to set this to 1 here. And now I'll go ahead and click OK. And we're going to run this regression tree again. I'm going to go to Stat, Predictive Analytics, and then Cart for Regression once again. In fact, this time I'm going to click on Storage because I'm not going to store these predictions. And I'm just going to go ahead and run this tree again. And now you'll notice that we have a different regression tree than we had before. There are 23 terminal nodes as opposed to 18 in the previous tree. And if I come down here to take a look at my variable importance graph, in fact, I'll enlarge it so you can see that a little bit better. In the previous tree that we created, the state was the most important predictor. So exactly what I described was happening here. The state had a lot of levels and it was sort of taking over our model. Here you can see that what's really more important is whether the person feels valued as a customer and the transaction type. And while the state is still relatively important, it's maybe not as important as we thought initially, right? So that was my overview on setting penalties for specific data conditions. And if we run back here over to PowerPoint, I just want to point out one more time that we have both options for high-level category penalties and missing value penalties. You can set those separately for cart regression and cart classification within file options. All right. And so this takes us to our final section of today's presentation. I want to tell you a little bit about results best practices. For this, we are going to return to Minitab here briefly. Let's go ahead and do that. Let me bring my Minitab back. And to do this, we're actually going to run the same regression tree one more time. And this time I'm going to click this button here, Edit Last Dialog, to just bring up that last window so I don't have to find this option through the menus again. And let's talk about some tips for best practices with your results. And so to do that, I'm actually going to click on this results button within Minitab. And I'm going to check the last box in this window. It says criteria for classifying subjects in Decay terminal nodes. What do we mean by that? I think it's easier to see once we run it. So let me just run this tree one last time. I'll go to the view of my output only. And again, as you recall, when we have our tree, we can follow the rules down to figure out, what rules get us into that particular terminal node 1 over here. But because I stored those rules with the output, we can see that here at the bottom of the results. So what is this showing us exactly? Let me zoom in a little bit so you can see that better. So first of all, in this table, what we have are the terminal node IDs all listed. So for example, terminal node 1, the predicted value is 0.68. Again, those are customers that aren't very happy with the company. And if I wanted to know what rules get us into terminal node 1, I can just come down here to this table and take a look at terminal node 1. We can see the person said the website is not easy to navigate. They didn't feel super valued as a customer, and so forth. So we can see the rules that get us into terminal node 1. Again, just a nice alternate way to see the rules that get you into each of the predictions. Something else that was introduced here in Minitab version 19 is the split view, which is a great way to compare your results. Maybe you're comparing between two different models, and maybe one with a higher R-squared, a more complicated one. In this case, we're comparing our models with and without the penalty that we set. So what I did is I just right-clicked on the output and I selected Open in Split View. And that lets us see our results side by side. We could split that beyond what we have there. If we wanted to see another piece of output, we could split it 3 different ways or more. But it's just a nice way to see your output side by side and potentially compare and contrast between different models. And then the last thing that I want to point out here is that once we do have the final model, let's say it's our 23 node regression tree here, I might want to send these results, export them externally. And so my last tip here is that we can send the results to Microsoft PowerPoint or Word, and we can export our results to Minitab Workspace as well. And for those of you that are not familiar with Minitab Workspace, let me pull it up here, is a desktop application that works together with Minitab. It has all of the essential visual tools that you need for problem solving. So in Workspace, what I like to do is document the results of my analysis as part of like a Six Sigma project, where we can use methodologies like DMAIC, PDCA, or we can customize our own. And so what Workspace has, it's more than 90 tools and forms that are built in, but tools for doing things like developing a new product or process, like DFMEA, Kano model, or voice of the customer plan. We've got decision-making tools like a project prioritization matrix, root cause analysis like 5 whys and idea maps, tools for organizing and executing a project like Gantt charts, and stakeholder analysis, lean tools like the value stream map that you see on your screen, as well as brainstorming tools like fishbone diagrams, CTQ trees. We also have Monte Carlo simulation, just to name a few. And so, as I mentioned, within Workspace, you can also go ahead and customize your own forms. And in my case, I've created a custom form that I like to use to document the results of my cart analysis. So if I insert that here, I can bring over the results of my cart tree to document and include here as part of my project within Minitab Workspace. So let me go ahead and jump back to PowerPoint to recap. We talked about results and best practices. You can add the classification rules to the results display for cart, and that's going to give you a list of the terminal node IDs with the corresponding rules that get you into each of those final groupings. You can also open your results in split view. Again, that's a nice way in Minitab to visualize multiple models or sets of output side by side. And you can also use Workspace to document your analysis results from Minitab as part of a Six Sigma project, or access the visual problem solving tools in Workspace from within the Minitab interface. So if you haven't already tried Workspace, or you haven't tried Minitab 20, whether the desktop application or the new web application, we do have free 30-day trial available. We'd encourage you and invite you to download your trial and start that today. And with that, thank you so much for being with us today.